Hi, today I am going to present the topic directivity measurements from the subject antennas and wave propagation. In this presentation, I will explain the concept of antenna directivity, different measurement methods, instrumentation used, and the important factors affecting measurement accuracy. Directivity. Directivity describes how effectively an antenna concentrates radiation in a particular direction compared to an isotropic antenna. It depends only on the radiation pattern of the antenna. When theoretical calculations are difficult, directivity is determined experimentally using measured radiation patterns. These measurements are especially important for validating antenna designs and analyzing complex antenna structures. The experimental process begins by measuring the radiation characteristics of an antenna at different spatial positions. These measurements are usually taken in the far field region on the surface of a sphere with constant radius. Two main methods are commonly used: approximate calculation based on beam width and numerical integration using sampled radiation data. This is the simplest method for measuring directivity, but it may not be highly accurate for complex radiation patterns. The E-plane and H-plane radiation patterns are measured first. From these patterns, the half-power beamwidth values are obtained. Using these beamwidth, the directivity can be estimated quickly. This method works best for antennas with a single main lobe and a very small side lobes. The accuracy of directivity measurements depends greatly on the spacing between sampling points. Highly directive antennas with narrow beams require dense sampling to capture all pattern details accurately. Antennas with wider beam can be measured with fewer points. The collected radiation data is generally stored digitally for processing using specialized software. Radiation patterns are measured using cuts, where one angle changes while the other remain fixed. Elevation cuts measure radiation changes in the vertical direction, while azimuthal cuts measure changes in the horizontal direction. By combining several cuts, the complete three-dimensional radiation pattern of the antenna can be reconstructed. Directivity measurements must also consider antenna polarization. The total directivity is obtained by combining the directivities of two orthogonal polarization components. Measurements are performed in multiple planes to capture both the desired polarization and the cross-polarization effects. Choosing the correct coordinate system is very important for accurate polarization analysis. Antennas with circular or elliptical polarization requires special measurement techniques because the wave polarization rotates continuously. Specialized probes or rotating linearly polarized antennas are commonly used. During measurements, it is important to separate the main polarization components from unwanted cross-polarization to ensure accurate results. Modern antenna measurement systems are highly automated. Sophisticated instruments such as network analyzers are used to measure radiation characteristics accurately. Rotational pedestal help position the antenna precisely at different angles. Computerized systems can process large amount of radiation data and calculate directivity automatically in real time. Several factors can reduce measurement accuracy. Reflections from nearby objects or the ground can distort the radiation pattern. Measurements must always be performed in the far field region to obtain stable results. Other important requirements include frequency stability, proper antenna alignment, and good impedance matching. For antennas with complex radiation patterns, numerical integration provides more accurate directivity calculations. In this method, radiation intensity values measured at many points are integrated using computer software. This allows accurate calculations of the total radiated power in all directions, resulting in a more reliable directivity values compared to simple beamwidth methods. To summarize, Directivity is an important parameter that describes how effectively an antenna focuses energy in a specific direction. Different methods such as beamwidth approximation and numerical integrations are used for measurement, and accurate results require proper sampling, polarization handling, advanced instrumentation, and error reduction techniques. Thank you.